Here, let's talk about basic NLP tasks. So what is NLP? Once again, natural language processing is any computation manipulation of natural language. Let's note that natural language, unlike, well, actually similarly to artificial computer languages, but even more so, natural languages evolve organically. New words get added, old words lose popularity, meanings of words change, and also, of course, one word may have multiple meanings, and the same meaning can have multiple words. Language rules themselves may change. Words like selfie is a new word, didn't exist that long ago. Thou used to exist, but no longer used. Learn can have multiple meanings, or the meaning of learn may change over time. Positions of verbs in sentences may change as well. So the processing of language is very difficult because of these characteristics. Note that when I'm talking about natural language processing, or when people are in general talking about natural language processing, it's roughly equal to text mining, and it's also roughly equal to text analytics. Now, some people will differentiate these a little bit in their own context, in their own books, in their own presentation. So always pay attention to that, but generally these have the same, almost the same meaning. I would say that NLP is a little bit more broad, as the name suggests. So it's processing of both text and other kinds of natural language, such as in sound, whereas, of course, text mining is the processing of text. And text analytics is also the analysis of text and not other kinds of natural language formats. So a broad list here of NLP tasks are the following. So counting words, counting frequency of words. Often we want to count words of the document to understand the length of documents, or to understand what's the important concepts of a set of documents. We'll count the frequency of certain terms. Finding sentence boundaries. So this may be useful to, well, to understand the sentences. So especially in kind of social media context, sentences may not be very clear. So you know, there might not be any sentence, see you tonight, okay? See you tonight, okay? Or there's no punctuation, things like that. Sometimes even in regular formal text, you may have things like semicolon instead of the end of a sentence, or not part of speech tagging. So identifying verb versus noun versus adjective, and so on. Parsing the sentence structure, so breaking a sentence structure down to its elements to understand the different components of the language. You can do this for various reasons, just to simply understand a piece of text, a document, or how language evolves. Identifying semantic roles, so who did what to whom, things like that. And that's kind of related to also part of speech tagging and parsing, which is identifying, for example, the subject in the grammatical sense versus the object of a sentence. Identifying entities in a sentence. So we talked about this. Who are the people? What word refers to an actual person or entity or company? It's not very, for humans, it's relatively easy to tell, especially if you know the context. You know, CDC recommends. CDC is an entity. Recommends is a verb. For the computer, however, how does the computer, quote unquote, know that CDC is an entity, is an organization? It doesn't unless you structure it, or you make it explicit in the computer itself. Finding which pronoun refers to which entity. So this applies in conversational analysis. You know, he did it. He did it. So there's a long story, there's a long piece of text, and then it goes and says he did it. Well, who is he? And they talked about two different people. Is he the first person or the second person? And so on. So this is a broad spectrum of different kinds of natural language processing tasks that are usually sought out. So let's look at an example here. The very base, some of the simple ones and about, for example, counting vocabulary of words. So assume here we have a set of a text, so text 7, and this text 7 is a set of sentences from the Wall Street Journal articles, and we will identify sentence number 7. Sentence number 7 in this particular article is Pierre Vinkin, 61 years old, notice how the commas are separated as it's a different word or different token. We call these token in text mining, and we'll talk more about that later next week. We'll join the board as a non-executive director November 29. So some basic functions that we usually have in Python is length. So get the length of the sentence, 18. Now these are 18 words, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Not words though, 18 tokens. These the separate components of it, the sentence. Now you may ask, why is this not dot here, not a new token? This dot is, well, because this dot is just abbreviating this word and so on, whereas this is the actual final period. You can also get the length of the whole text. Now, the length function may apply to letters or to words, depending on what you're applying to. So in this case, well, it depends on what this text here. I think this has to do with the number of tokens, but it really, yeah, it depends. So, and then you can also length of the set of text 7. So this is the length of the set of text 7, which has to do with, maybe in this case, the number of individual sentences, or it could also be the number of individual articles. So it depends on what this text is. And I don't recall nowadays which one, if it is what we call a corpus of sentences, or a set of sentences, or it could be a set of articles. So you need to know that as you're working with your own data. Another kind of simple NLP tasks is finding frequency of words, which may be useful. And here we can use, this example is using the NLTK library, Natural Language Toolkit. So this is a function, frequency distribution function that you apply to a set of text, and it actually counts the distribution of all the distinct words. So the length of this distribution is 12,408. And I think this, once again, maybe the set of articles. You can get the keys of this distribution. The dist is the distribution, the frequency distribution that we apply to text 7. And then we can list. This is another function. Every time we see this parentheses, right, a kind of word with the parentheses, we're talking about functions. So list vocabulary 1, so list the keys of this distribution, which looks to be like the tokens. But we only list up to the first 10, 0 through 9. And here's just then that prints out the list of the vocabulary, the tokens from 0 to 9 of this frequency distribution. And you can use the distribution function itself. So dist is, dist is the variable we created that printed out the distribution result of the frequency distribution function. And when you write it this way, dist, that is the variable you used here, and the square brackets, and you identify the word you're looking for, it tells you how many instances it occurred. So the distribution of the word for is 20. So that means it occurs for the word for, F-O-U-R, occurs 20 times in this text here that was fed into this variable. Remember, U just means that this is in Unicode format. So it's already telling you the encoding, so there's no ambiguity. And then you can also apply other Python functions. So for example, this is a kind of Python shorthand for, they call list comprehension. So essentially it's going to print out item for item in vocabulary one if the length of the item, that is the length of the number of letters, is greater than 5, and the distribution of the item is greater than 100. So I want all the words that are over 5 letters long and also had appeared in this whole text here more than 100 times. And then you can see the words million, shares, market, president, trading, billion, company, program, and because. So all these words here are longer than 5 letters and appeared over 100 times in this text. And we'll also apply some of these in the following lab that we have for this class to get some practical application. So some of the basic and advanced NLP tasks are, as we mentioned, this counting of words, counting of frequency, and we kind of went over this. Here I have some more of the formal names of some of these tasks. So for example, named entity recognition is the set of tasks for identifying entities, or co-reference and pronoun resolution as well. We'll probably not explore these in this class, but it's good for us to know, and we will indeed explore some of these in the following lectures. That's it for this one. I'll see you next time.